Now, the other thing that you all need to know is this. Next time we have class is your first unit quiz. The stuff that you need to know is how to go through and simplify radicals. You need to know how to rationalize denominators. You need to know how to go through and solve radical equations. If we've done it so far this unit, it's fair game. The questions that I got, most of them are literally, I think it's 4 or 5 questions from the homework. Like I didn't even change, I think most of them I didn't even change. Maybe 1 or 2 of them are from the notes. But you need to know how to go through and do them. So make sure, please, that now you all, we don't have class again for another day or 2, so don't let that linger. What page did we leave off on for notes? 15? All right, make sure, please, that you have your notes out and open to page 15. Now, take a look, please, at the first question for 1A. If your task is to go through and solve this out, let's start off with this. Right away, we should recognize, by the way, Stephen, how many answers will this question have?
8.
Yep. 2. It's a quadratic equation. In general, our process then is set it all equal to 0. Try to go through and the methods that we have normally for a quadratic is going to be to factor. Except this one makes itself a little bit easier if I don't factor. Hands up, please, if you can tell me what I could go through and do in order to solve this question out. You could take out a GCF of 5. There's no middle term here, so I can go through and isolate and then take the square root. So if I do that, I have 5x squared is going to be equal to 100. What would you do next? Caleb?
Take the square root of those sides.
Not yet.
Oh, divide by 5.
Divide both sides by 5. So we're going to get x squared is equal to 20. From here, Michael, what would you go through and do next?
Take radicals. X equals radical 5.
Now, and right now I'm going to say, there you go. You've got to make that connection that since it's an equation and you're solving, that means that there's going to be 2 answers. This would not be an acceptable final answer. Hands up, please, if you can tell me what you would list out as your final. We've got 4 people. Really? No. That 20, I got the problem with. Well, yeah, so what would you give out? You've got to recognize that you can, and at this point, you're okay to take the square root in your head. That's something you're supposed to be able to do. Square root of 20, biggest perfect square that goes in, it's 4. Take the square root of that, it becomes your coefficient. Whatever is not a perfect square remains in the radicand position. Questions on that? Now, these have all worked out nice and easy until something like this shows up. Aaron, what would we do to start this off? Terrific. So I would get 2x squared is equal to negative 2. 2x squared is equal to negative 2. Next thing up, Felix, what would you go through and do next? So you get x squared is going to be equal to negative 1. Now this is the part where, well, we'll continue on. And kind of what would you do from here?
I take the square root.
But what are you apprehensive about?
Square root of negative.
Up until now, you've been told, and correctly so, you can't take the square root of a negative value. So what happened in mathematics was this. We're doing all of these problems. Mathematicians encounter this error over and over and over again. And there's this one door we can't get into. So instead of saying we've hit a roadblock, there's nothing that we can do. And instead of giving up, they were problem solvers. They said, yeah, you know what? This is what we're hitting. But maybe we're being a little bit unrealistic. Maybe we're not thinking about everything. It's sort of like almost like a parallel universe. Right now, we've had real numbers. And by real numbers, it's an amount that you can go through and hold. Real number is you can have sort of that many apples. So you can have 5 apples. You can have 4 apples. You can have 7/2 apples. You can even go through and have the square root of 5 apples. It would be 2 and some change. But the square root of -1 is the one thing that we haven't been able to unlock. So what we did was we said, instead of giving up and throwing in the towel, we said this. I'm going to invent and make -1 a perfect square. I'm going to say that the square root of -1 is equal to an imaginary unit called I. And once I do that, a whole other branch of mathematics is opened up. You're dealing with imaginary numbers. You have to understand this, and we're not going to go into all of the applications of it, but there's really, really cool stuff that comes, especially when you start graphing them. But what we're going to deal with now, you have to know that 4 is a perfect square, 9 is a perfect square, 16, 25, 36, 81, 121, 144. All of those are perfect squares, and so is -1. Because if you let -1 be a perfect square, everything else, or at least the mathematics that you do, is going to become kind of easy. So at this point, I'd say x is going to be equal to the square root of -1 is I. Are we okay with that? Raise your hand if you're okay with that. Who is mad as hell that there's a mistake up on the board right now? You may throw your pencil at me if you want to. You're so outraged and offended, and you're going, this is garbage. I can't believe that lazy Larry forgot all of the stuff. We've said it already 2 or 3 times today. What? It's plus or minus I. You're still going to get 2 answers. You guys are like sheep. You really are. I say something, you go, nah. Thing! We already said it's an equation, x squared, that's going to have 2 answers. That was the first thing we did. So we get to here. Recognize that the square root of -1 is a perfect square. Now, we'll go through and we'll break this down. We're going to give you out so we have, and we need to know, this is called the wheel of I. It's a good way of remembering I to various powers. Keep in mind, we know right now I is equal to the square root of -1. Now, we're going to be able not only to evaluate and simplify now, but we need to evaluate out this imaginary unit to a ton of different powers. Let's take a look at the first one. The first one I want to look at is I to the 0 power. Hands up, please, and tell me what I to the 0 power is going to be. And let's be careful about this. No, that would be I to the first power. It's going to not be 0. 1. Any base to the 0 power is going to give you 1. What about I to the first power? Well, that's just an I. The interesting thing comes if you can make the connection with what I is, to then be able to tell me what I squared would be. Who can tell me what they think I squared is going to be based off of the definition of what I is? Why would it be -1? When you take the square root of -1 and square it, you're left with just the radicand. Those are inverse operations. Now, this is the most interesting one if you can see it. I to the 3rd power. You can tell me what they think I to the 3rd power would be. 1. No, not 1.
-1 times square root.
Which would be just? No. -I. Here's the justification. Remember, you got I to the 3rd, and you can get what the value is by breaking it down into known values. I to the 3rd comes from taking I squared times I to the 1st. When I'm working with this, you've got to understand I squared, again, it's the square root of -1 squared, which would be a -1, times I to the 1st, or -I, so we get -I. That's why it is what it is. Now, you should be able to notice some parallels if we view this almost like a compass. When I go on this north and south, we've got 1 and -1. When I go east to west, I've got I and negative I. And these, furthermore, are cyclical, meaning it goes in a cycle. When I do this out, let's understand, let's do this. Understand, please, that every number that you've done so far technically is written in this imaginary unit form or A plus BI form. The A is the real number, and the BI is the imaginary component. So technically, when you've been telling me 5 or 7 or negative 3 is an answer, you've been telling me 5 plus 0i, 7 plus 0i, negative 3 plus 0i. If there's no imaginary component to it, it's 0i. Now, let's go through and process what we know. Let's see if we can get some of these things down first. Let's start off with this, and again, recognize that these are cyclical. It's a repeating pattern. I to the fourth, notice that our wheel of I starts at 0. So we would go 0, 1, 2, 3. I to the fourth would have a value of what? No? Count around. We've got 0, 1, 2, 3. I to the fourth falls on top of I to the 0, which is 1. And you can keep counting around. Hands up, please, when you can tell me what I to the 7th is going to have as its value. Negative I. Now let's get into some that are more interesting. And some of you hopefully are going to see a pattern. How about I to the 12th? Hands up, please, if you can tell me what I to the 12th would have as its value. 1. Now some of you are going to see this right away, and it's going to be outstanding. Hands up, please, when you can tell me what I, or what you think I to the 101st power is going to end up being. Think about it. I to the 101st power, what would it be in Y? I to the 101st power. We got 3, 4. You want to give it a try? Why?
Because I took 101 and then divided it by 4, and it goes around 25 times, and then there's 1 extra.
What she did was she found in her head the closest multiple of 4 that was near 101. So you could have used 96, you could have used 100, she could have used 104. But remember that that's what's going to fall up top. And she said it perfectly. How many cycles around was it? Well, it was 25 times, but what was left over? 1 more. So you pivot up to the top at 25 cycles around, 1 more is that. So think about multiples of 4 that are nearby, and this would be an I. How about the next one, I to the 403rd power? These again are calculator free, and by now we hope that these should be. You need to use the calculator to find the nearby multiple of 4. That's fine, but let's go through and make sure we're getting it. What do you want to say? That's terrific. What multiple of 4 did you get? You could have done 400, and how many more did you go? 3. So this is the same as I to the 400th, and then 3 more, so I to the 3rd, which is negative I. Now, the reason that we tell you all this, because there's some, when we teach this class over at U of R, this is one of the questions that's on the exam. And it's calculator free. So we're sitting there, and we give this out to all of the students, and they're going, and see this. This should be kind of easy for you to do. But what ends up happening was this, and it's a 2-hour test, and we're sitting there and watching, and you start hearing this. Actually, what a headache sounds like when it starts is that ticking over and over again. They had to do it 307 times. Now,
Don't mess up.
the part, and by the way, they did screw it up when they did it. My favorite, though, was the person was sitting right here. There was another young lady sitting right next to him. This young man, he must have had maybe some rage or anger management issues because they were very, very hard, almost like a stabbing motion. He was counting his way around. So what ended up happening was, as they were counting around, you look over, and right next to him was this young lady, and God love her for not hiding her emotion. Literally during the test year. And I think that if her eyes had lasers, that one would have exploded. Just from the viciousness of the dirty look that was given. And not only did they get it wrong, but then the other part that's just outstanding was later on, you can hear the joy. And by the way, they missed all, which was even better. I mean, come on. When we tell you, it's like those of you that are still hanging on to that y equals mx plus b garbage and you're going through and solving for the b. I don't know, is it possible to do it right? Sure. I don't know why you wouldn't do it how we do it, though. So understand that when we do these, you've got to find a multiple of 4 nearby. Use that to help you out. And towards the, well, we've got one more part I want to show you before we go into practice on these. Let's do this. All right, so here's some radicals I'm going to ask us to go through and simplify down. Because let's be honest, we need to be able to go through and do more than the minimum. Who can tell me what they think the square root of -4 is going to be? You know what the square root of 4 is? What would the square root of -4 be? We got 1, 2 people that can venture to take a guess. Stevie?
2i.
2i. And it's not plus or minus 2i because the square root was not arrived at in the solving process. So this here would be 2i. What about the square root of -25? Hands up, please, when you can tell me what that's going to be. Terrific. Who can tell me what our next square root is going to be? Now, here's the one that's going to be interesting. How about the square root of -8? Think about that for a minute. It behaves very similar to the square root of 8. There's going to be one discrepancy. We've got 2 people who can tell me. Really? What do you want to say? Close. I want to change one thing about what you just said. No? Put your answers sort of together, Stephen.
2i times square root of 2.
Yeah, the I goes out front, so it's 2i times the square root of 2. The I needs to become a coefficient or bounce out front when you take the square root of it. Now, with that in mind, let's answer out question, the next one, which is the square root of -27. Who can tell me what that's going to be? We've got 1, 2, 3 of us. 4? Really? Really? How about the next one, square root of -300? Oh, come on. Come on. We're there, hopefully. Outstanding. Yes? Hang on, I'll show you right now. Now, let's look at this next one. Remember how before we listed it out the long way, so I'll do that for you now. This is going to be the square. What's the biggest perfect square that goes into 300? Nope. What's the biggest?
Whatever.
Nope. What's the biggest perfect square that goes into 300? 100 times 3, and then you need a -1 in front. So what's the square root of -1 going to be? Well, we established that the square root of -1 is how much? I. This would be 10. So it's 10i root 3. Okay? Questions on that? Now that we have that, that means we should be able to rip through pretty much all of our questions today. Take a look at question number 2. We've got 18 plus 3x squared is equal to 6. What would we do next from here? Deanna, what would you say? And what would you be left with? What's your new equation going to look like? We got negative 12 over here, and what's on the other side? What would we do next from here, Jordan?
You would divide 3 by both sides.
And you're left with?
When simplified, negative 4 over 3.
No,
Oh, it's just 4 over
just negative 4. What do we do now from here? Rebecca?
You put square root of negative 4 when it's positive or negative.
Plus or minus what? Should be 2i. Square root of 4 with an I tacked onto it. Questions on that? Let's go forward. Next one's up. We're going to simplify these down. Take a look at the radicals that are given. And Angela, what's the square root of negative 25 going to be? Good. So this would be 5i plus, what's the square root of negative 49 going to be? Jake? What do I get when I put those two like terms together? Joshua, what do you say? How about for b? What's the square root of negative 8 going to simplify down to be? We've already actually done this one today. Hands up, please, if you can tell me. Square root of negative 8, what's that going to simplify down to? 4 of us? Olivia C? How about the square root of negative 18? So all the hard work now is done. We can now subtract those. And Angel, what would you be left with when you did that? Yeah. 2 minus 3 gives you negative 1, so negative 1i radical 2. Questions on that? Next one up, we need to simplify out using these powers. Now I hope, based on the work that you told me before, that these are so fast for you. Who can tell me, please, what I squared is going to equal when we simplify it down? Seriously? Jordan, what do you think?
negative 1.
Outstanding. How about I to the 40th power? Hands up, please, if you can tell me what I to the 40th would be. 1. How I got that? Which one? Number 5? Remember, here's our wheel, right? We've got I to the 0, 1, 2, and 3, right? Where's 40? Because remember, all the multiples of 4 land up top. So what multiple of 4 is going to land up top? 40th, and I to the 0 is 1. Always find the nearest multiple of 40 multiple of 4 when you're doing it. So you have to know your multiples of 4. That means we're asking you to do things like identify 32, 36, 40, 44, 100, 200, because every multiple of 4, its multiples will be multiples of 4. So 100, 200, 300, 80 is going to be there, 40 is going to be there, 44, 88, etc. Yeah?
So if you don't start on the top one, you start by jumping. You don't count 1, 2.
Right, it starts at 0 up top. It goes 0, 1, 2. Okay? Otherwise, your answers will always be 1 off. Now, an easy way to remember, 0 isn't a multiple of 4. Okay? Take a look at the next one. 8 times I to the 82nd. So this is 8 times something. Go through right now. Hands up, please, when you can tell me what I to the 82nd is going to be equivalent to. Find a multiple of 4 that's right nearby and use that to determine what I to the 82nd is going to be. We got 1, 2, 3, 4 of you, 5. What do you want to say? -1. What multiple of 4 did you recognize that was near 82? 80. So we start off 80 up top, 2 more, puts me down below at -1. So your answer should be -8. Next one up, -3 times I to the 266th power. So hands up, please, when you can tell me what I to the 266th power is going to be. Find a multiple. You don't. It's not math magic. If you need to go through and use your calculator to find one that's nearby, go through and tell me how many. We got 1, 2, 3, 4, 5 of us. We can get there. We'll wait for 9. Again, if you don't know, you don't get it by staring. Try multiples of 4 that go near 266. If 266 isn't a multiple of 4. We got 1, 2, 3, 4 of you. 5. Come on. Come on. What'd you get? -1. What multiple of 4 did you use that was near 266? 264. And then that means 2 more. So that means in terms of the wheel that you would draw, I to the 264 is up here, so I to the 266 would be here, which would be -1. So our answer simplifies down to be a 3. Questions on that? Oh, hello. I to the 23rd, hands up please, and you can tell me what I to the 23rd is going to simplify to. Again, think about your multiples of 4. Where is this going to put me at? -I is correct. You could have used 20 or 24. What about 12? I to the 41st. Hands up, please, if you can tell me what that's going to simplify. What I to the 41st, excuse me. It's going to simplify down to. We got 1, 2, 3, 4 of you, 5. And then you multiplied them and got 12i. Questions on that? Then let's keep going. -8 times I to the 93rd. Hands up, please, if you can tell me what that's going to give us. We've got 1, 2, 3 of you. Oh, come on. I to the 93rd. Find a multiple of 4 that's near 93. What multiple of 4 did you use?
92.
So I to the 92nd falls here. I to the 93rd would be here. So -8 times I, which would be,
-8.
there you go. Questions on that? Next one up. I better not hear the pecking. I to the 501st. Hands up, please, if you can tell me what multiple of 4 is near 501. We got 1 person, 2, 3 of you, 4, 5, 6 of us, 7. We're getting there. We're getting there. You know? Okay? What multiple did you use? You're right. There you go. 500 would be up top, so 501 puts us at I, so this would be 4I. Questions on that? Next one's up. Now, so far this year you've learned about the Cartesian plane. You've also learned about lattice points. Now we're going to go through and talk about the Argand plane. The Argand plane is easy to go through and work with, but again, we had a problem, so we found a solution to it. We only so far in the Cartesian plane can plot an x comma y, but they're both real numbers. We need now to go through and deal with what's going to happen with a negative number. So when we do this out, we've got our real and our imaginary axes. So what we're going to do is this. We're going to label this, our real number is x. Our imaginary number, or our imaginary axis is yi. Remember how we said that the numbers were in the form a plus bi? So the numbers that you get in a plus bi form are actually giving you a coordinate to go through and plot. Now the first one that we go through and plot is going to be -3 plus I. So we're going to graph this out. Here's your x and here's your yi. In terms of the x, how far am I moving left and right? Well, I'd have to go 3 to the left because that means the x would be -3. and then I've got to go to yi, which is positive 1i, so I go here. This would be negative 3 plus I. Now, if you stop there, you are incorrect and won't receive points. You have to understand that these coordinates on the argand plane are vectors. So you need to draw a ray with the center of the origin going out to that point, and the tip of the arrow should be right at that value. Yes? Because it's, what's the coefficient in front of the I? 1. No. You're graphing that value. Negative 3 plus 1i. Okay? That's it. Now, by the way, hands up please. Which quad did I just graph that out in? Hands up please and tell me which quadrant number did that get graphed out in? 1, 2. Next one up is 2 minus 5i. Before we do that, hands up please if you can tell me which quadrant that's going to fall in. 2 minus 5i. Which quadrant would that fall in? Terrific. Let's go over 2 and down 5. So go over 1, 2, down 1, 2, 3, 4, 5. So over here I'd have this, and this would be 2 minus 5i. I go through and sketch from here over to here as accurate as I can and label the coordinate. Questions on that? Let's go through now and express these in simplest form. These are our last ones for the day. Looking at what's there, this part's going to be awkward. What's the first thing I would need to do in number 13 in order to simplify it out? Follow our basic tenets of algebra. What's the first piece I would need to go through if I'm asking you to evaluate out number 13? We got 1, 2. What's that? Which exponent? Yeah, we'll start with the 7. And what do you have to do with it? Who can tell me why we start with the 7th power before the 81st? 2, 3 of you? 4? We need to evaluate out what that's going to be. So we need to take and evaluate out that expression. The other ones don't have any simplifying to do. There's still algebra to do in this. Go into your calculators right now. You need to take 5 to the 7th power and I to the 7th. Hopefully you know I to the 7th would be I to the 7th. But what's 5 to the 7th power going to be? What'd you get? Go ahead.
78,125.
So 78,000, you said 125?
Yeah.
And then I to the 7th times, this would be 3 times I to the 81st times. Now I'm going to do something here, 2I to the 1st power. Because if I don't do that, you all are going to screw this up and make a dumb mistake right now. Looking at what's there, we're going to multiply going across. So that's what you all are going to do right now. Hands up, please, when you can tell me what you get when you multiply those 3 coefficients going across. So we're aware, again, coefficients are the numbers in front of a variable or a term. We've got no persons that have multiplied it together. Congratulations, 2 of us. Thank you. Thank you. 3 of us. We're going to get a big number. That's what's to be expected. 4 of you. 5, 6. Spencer, did you get it? 700 what? Okay. And now it's going to be I to what power? Hands up, please, if you can tell me that. What power is the I going to be raised to as we go across? 89. Why is it to the 89? How did they get that number?
Multiply exponents, the values add to each other.
There you go. You have to, when you're multiplying with like bases, you add going across. Now this needs to be simplified down. So I need to find a multiple of 4 that's near 89 to help me with the simplifying. We've got 1, 2 of you, 3, 4.
It's going to be multiple is 88.
There you go. 88 would fall up top. 89 is 1 over. So 4, 6, 8, 7, 5, 0, I. Now, for our last step for today, we need to evaluate out. So what you all are going to do here, first row, you kids are going to go through and simplify I to the 488th power. Second row, you kids are going to do I to the 113th. Third row, you kids are going to do I to the 227th. And fourth row, you kids will do I to the 18th. Go through and evaluate those out right now, please. Hands up when you've got what replacement I'm going to make for each of them. We got 3 people in the first row that can tell me. 4. Who can tell me in the second row what 113, I to the 113th is going to be? 2 of us? Really? Really? I. 112 is the one nearby. You go 1 past. How about 227? Go ahead. Negative I. And how about 18? Negative 1. So now let's simplify what's there. I'm going to go, all right, well, this is 7 minus 3I. And then minus 5I, because it's 5 times negative 1, then plus 6. Let's condense this down and give it an A plus BI form. So when I do that, Maddie, what would you get when you put the numbers together? 13 minus 8. Now, make sure you sign into your calculators. Looks like everyone has. What we need you all to do now is this. Go back, make sure you're on a document, please. And what we're going to have you do is this. Now, again, please understand, one of the things that we're going to encounter a ton of issues with is the courses that you were in before, from what it sounds like, people told you a bunch of garbage that's going to only get you through a Regents exam. We're going to do actual math, and the calculator can help you, but it's not designed to wholly supplement what we're talking about. That's why we have calculator and calculator-free sections. So what I'd like us to do is this. We're going to find the I button. Let's go through and input that last question, please, which was, how did it start off here? So go in and do 7 times. Now, you find the I button by pressing the pi and arrowing over. So 7 times I, and you're going to raise it to the, was it 488? And so on. Input the rest of what that last question was and watch what the calculator gives us. Now you'll understand why. And again, there's techniques that we're going to show you that will work fabulously on the Regents exam. They're terrific ways to check your work, but at the same time, they're not supplementals for actually knowing the why. Some of us get addicted to just going, oh, it's this, I plugged it in my calculator, and then some math magic happened. Does that match what we got last time? Yes or no? Absolutely it does. And if you ever get stuck and you're at home and you want to know whether or not you got the right answer, that's one way of going about and achieving to see if there is, in fact, equality in what we're talking about. But at the same time, and again, on the Reg, I could care less what you do. Show it all out, or show nothing. If it's a multiple choicer, you could literally plug it into the calculator. That's why the Reg won't ask you something as computation-based as that. Because you can go through and just type it in and you're done. Okay? Questions on that? Now, we'll give this to you all. Where's 2.5? Here's the answers to your homework. Okay? We're going to have your tests and stuff handed back now. Can you hand these kids back for me? Can you hand these back for me, please? Can you please hand these back? Can you hand these back, please? And can you hand these back, please? Thank you.
Hey,
Yeah.
what?
What? We're going to find out.
That's over there.
Oh.